Submarines are big, complicated systems that operate underneath the ocean surface. The heat generated from these onboard systems needs to be removed to maintain livable conditions for the crew. As a submarine is surrounded by an abundant source of seawater, a heat exchanger can be used. Heat exchangers are used in a vast variety of engineering applications to transfer heat from one medium to another, with the most common configuration being the shell and tube heat exchanger. And I've got one right here. As you can see, one of the fluids travels through the tubes and the other fluid travels through the bundle over the tubes, and that's where the heat transfer occurs.
In many applications, the size of the heat exchanger cannot be changed. Therefore, the alternative is to improve the efficiency. Literature has proposed that dimpling of a tube surface increases the rate of heat transfer. The dimples essentially have a tripping effect on the fluid, causing increased mixing of the fluid. Cooled fluid on the surface of the tube mixes with the yet-to-be-cooled fluid at the center of the tube. This increases the delta T. Convective heat transfer relies on a temperature difference. The greater temperature difference results in a greater rate of heat transfer. However, these modifications could increase the pressure drop across the pipe. This needs to be considered when evaluating these dimpled designs.
CFD simulations were ran for all tubes at 4 different flow rates ranging from laminar to turbulent flow conditions. The dimpled tubes proved to increase the heat transfer through swirling the fluid and mixing the cold outer layer with the hot inner layer of water. The most significant increase is during laminar conditions. The maximum increase in heat transfer was 22%, with a pressure drop increase of 37%. Future work on the project is to perform real-world experiments where tubes are placed into a water tunnel and temperatures and pressures are recorded at the inlet and outlet of the tube. These results will be compared to the CFD results for validation.